Okay, year 12, physics. Talking about momentum. The symbol for momentum is the Greek symbol rho, but you can call it a P if you want, it's pretty well the same. You need to bear in mind the laws of motion while we're dealing with this. So Newton's first law, an object in equilibrium, that means the forces are balanced, will have a fixed velocity. Second law, if you've got an unbalanced force, the object is going to accelerate, which is F equals ma. And the third law, any action force is going to have a reaction force in the opposite direction. Formula, F equals ma, we're going to be looking at, and this formula A equals change of velocity over t. But this will change slightly because we're going to say if the change of velocity is the final minus the initial, which is true, it's a change of anything, it's final minus initial. But if VI was 0, then the change of velocity will actually equal its current velocity. All right? Looking at this, we want to know what momentum is proportional to, and then we can look at the formula for it. So, bearing in mind, this is my little firing thing here, so we can have a fixed force. So if I push this with a force, it goes really fast until it crashes down there. If I take 2 trolleys though, what have I done? Changed the mass of the object. So if we do the same thing again, it's not quite as fast, is it? What would happen if I took 3 trolleys? Really slow, and with 4 trolleys, very slow. So clearly mass is involved in this. So momentum is proportional to mass, and what else? Let's go back to 1 trolley. Here's 1 trolley. It's going slowly. It doesn't have much momentum. Again, it's going fast, it has more momentum. So its velocity is involved in this as well. That means momentum is proportional to mass and velocity. The formula is really easy. Momentum equals mass times velocity. Interesting. When we come over here and look at these formulas again, you can take the A, what it's equal to, put it into this formula here, which will give us F equals mv over t. A little bit of very simple algebra, and you get Ft equals mv. Now, what does that mean? You know that is momentum, mv is momentum, so Ft must be momentum as well, but what does it really represent? Let's go back to our trolleys. There we go, it's 2 trolleys. Here's my firing thing. If I push this with a little force, it doesn't get much momentum. If I pull it all the way back and push it with a large force, it gets a lot of momentum. That must mean that the force is changing the momentum. Now, if somehow I was able to push this for a limited amount of time, but with a large force, it still won't get much momentum. So the Ft, this bit here, actually represents change of momentum. Which means that the momentum that we've given to the object came from the force applied in the first place, which is an action force, and the time it was applied for. That also means that we can have another formula. So this word would go to change of momentum equals Ft. That is often called an impulse. And it also means that change of momentum would have changed the velocity. So that would be mv f minus mvi. Now, those of you who are really good at algebra and understanding all this will realise that if it was stationary to start with, that bit there, that's the start, isn't it? I have to draw it here. That's the start velocity. So if the start velocity was 0, then change of momentum will equal mv, which is exactly what I said here. So v, the change of velocity, would equal vf on there, the little f there, which kind of ties the whole lot together then in terms of momentum. Right, next video we're going to talk about collisions and explosions and what it does to momentum. All right, hope you enjoyed. Any questions? I'll just take a quick close-up of the board. So if you want to pause it on that, got it there? Okay, good.